Hello and welcome to Factoring Trinomials. Today we're going to look at factoring some polynomials, but basically just looking at the trinomials where we've got three terms. Are all quadratic trinomials factorable? Well, today they will be, but in the future they probably will not. Here's your homework assignment questions to take a look at after you are done watching our two-part video series. Alright, so some new vocabulary. Quadratic equation, ax squared plus bx plus c equal to 0. We're just going to be looking at the ax squared plus bx plus c part today and worrying about solving them some other time. In order to solve them, though, we need to factor, so that's what we're going to look at today. Alright, algebra tiles. You should be a big fan of these from the last video and the last section. We've got the big box that stands for x squared. We've got the skinnier boxes, rectangles that stand for x, and the tiny little ones for our units. So we're going to look at solving x squared plus 5x plus 6 and factoring it. We've got our x squared term here that stands for our x squared. We've got 6 individual units along the bottom there that we need to make sure that we arrange into some sort of a rectangle. I've chosen to go with one row of 6 of them. So when I start taking these out, I know I only have 5 from my 5x portion of the trinomial. If I start putting these in here to line them up, we should quickly realize that we are going to run out. That doesn't even line up there, so we're missing another box that we need here, plus another one here. So going with a 6 by 1 down there in our digits column is not going to work for us, which is, I believe, what it's telling us right here. So let's take a look at this. We're going to take those, instead of doing 6 of them, we're going to put them into a box where we've got 2 by 3. Also makes a nice perfect rectangle for us. So now when I take my 5 x terms, they should line up a little bit better for me. And I'm going to magically make those flip over. So we'll pretend they aren't really there. So now I've got my situation where it actually makes the nice perfect rectangle. Everything lines up and makes my nice box. I don't have holes. So I know that this is going to work for me as far as factoring goes. And there, that's put together a whole lot nicer. So now we've got to decide, what does that mean as far as what of our two terms that we have factored into. Well, along the top here, we've got to decide what terms go in these two spots and what terms go in these two spots. So let's see what's going to fit there. This looks like an x fits and makes that particular spot, as well as this one. And then we're going to go with single digits here. As well as over on the left side. So that makes my terms start to look like I've got x plus 1, 2, 3 of these, and x plus 2 of those. So that gives us our final factored answer of x plus 3 and x plus 2. Which is all much nicer written out there. Now if we want to check our answer, we can go down here and use our box method that we were using to multiply things yesterday. I've got my x and my 3 on the top here, the positive 3, my positive 2. We start taking a look at multiplying things together. This times this one's going to give me my x squared in the top left. Continuing on my first row here, x times 3 is going to give me a positive 3x. Down here, positive 2x and positive 6. When we go and put those things together and combine our like terms across the middle there, we've got our x squared plus 5x plus 6 like we started with, so then we can feel good about ourselves and having done something correctly. Alright. So, are we done? Alright, so now we're going to take a look at factoring our x squared plus 5x plus 4 here. It's a similar looking trinomial, but we've got a different constant term there on the back end. So we're going to look at factoring that using our box method. We've got x squared plus 5x plus 4. Our x squared is going to go in the upper left hand corner, or right here. My constant 4 is going down here in the bottom right. So now we've got to look at what's going to multiply to make those two things. Well, the only way to make an x squared is to multiply x by x. So I'm going to get that taken care of there. Everything in my trinomial is positive, so I like to put plus signs there to make sure I know that those are going to both be positive. And what kind of things are going to multiply to make a 4? Well, if I'm going to multiply to make a positive 4, I've got a couple options. I've got a 2 times a 2 or a 4 times a 1. Now, only in one particular case are those going to be able to add up and make the 5x here in the middle. Well, 2 plus 2 makes 4. 4 plus 1 makes 5. So I'm thinking that my 4 and my 1 are going to be the winners. So I'm going to put a 4 up here and a 1 here. Start filling in my box. And those look like they are going to make it as far as my collecting like terms across the middle is going to make my 5x that I wanted. So those look like my two correct terms. So our final answer there is going to be an x plus 4 and an x plus 1. That's an 11. Awesome. Alright. That was exciting. Is that what we just did? It is. Okay. Alright, so here's a big long thing just talking about how we want to look for the 5x, and we got to think about what things are going to add up to the 5x in the middle but still multiply to make our 4. So we're just looking at what multiplies to make our constant term and what adds up to make our x term there in the middle. And that's what we already did. Alright. So, checking our answer using our algebra tiles. Across the top here, this looks like my x plus 1. And along the bottom here, or on the left side, that looks like my x plus 4. So if we start filling things in, we're going to have my x squared. It's going to match up there. Along positive x here. We're going to move some green x's over here to match these up. And then we're going to need a whole lot of little individual units to fill in the rest of our rectangle. So, how many do we have here? Well, we've got 1x squared right here in the middle. We've got 1, 2, 3, 4, 5 of those positive x's, and then 4 single units out here on the right side, which gets us back to the exact same trinomial that we were starting with a few minutes ago. Alright, so now we're going to be able to kind of choose whatever method we want to go with. I'm going to go with using some algebra tiles here and see how that works out. Alright, so since I've got my x squared here, I know I'm going to drag 1x squared and drop it up here in the left corner. Now I'm going to look at my positive 12 and think about I need 12 positive 1s. And now I might be regretting the fact that I chose to use algebra tiles, but I'm going to go with it anyway. Alright, so I'm hoping that 3 rows of 4 are going to work out for me, because that's going to make a nice box. And there's my rectangle of 12 individual units. So now I got to make sure that I've got 7 of these things. There's 4 and 3 more. Makes 7 individual x's that I'm going to have to match up in here and complete my rectangle. You kids at home have no idea just how fun it is dragging these x's around. You're really missing out with your pen and paper. So, I've got a nice perfect box I've got my 12 individuals in here. I've got my 1x squared. 4 and 3 are going to make 7, so I look good. Now I got to think about what my answer is going to be. So I've got 1x along the top, 1x along here, and then a bunch of individual units to match up on my different columns and rows. That's going to leave me with my final answer of x plus 4 along the top, and then over on this side, x plus 3. Alright. So this one I'm going to leave the algebra tiles alone. I'm going to take a look at using my box method because it's fun too. Alright, so I've got my x squared term here. It gives me an x and an x. I notice that both of these two things are positive, so everything's going to be positive. We haven't even looked at negatives in our lives yet, but I bet you can't wait until things get negative. So what multiplies to make it 10? Because I know we need to multiply in order to make that back number. 5 and a 2 does, and a 10 and a 1. Well, we also know that they're going to have to add up to make that 7 there in the middle when we put our two different terms together. So, which one of these are going to add up and make a 7? I hope you can come up with that conclusion on your own and find the 5 and the 2. Oh yeah. Oh goodness. That was horrible. So that one doesn't make a 7, it makes our 10. And so we're not going to use that one. So I'm going to put my plus 5 on this side, my plus 2 here. Gives me 2x and 5x. So we've got our final answer of x plus 5 and x plus 2. And I think that's easier than the algebra tiles, but the algebra tiles are pretty. So you use whichever method you think is going to work for you. You can try example 3 here on your own, so go ahead and hit a pause and see if you can figure out what's going to multiply to make the 15 and add up to make that 8. Alright, so here we've got something different. What's different? Well, I'm sure you're looking at the negative sign and you already got scared because there's a negative. What are we going to do with that? Well, what that means, well, let's start out. We've got x squared here, so we know that these are going to be positive x's. Now we've got to think about what kinds of things are going to multiply to make a positive 9, but when you put them together, they're going to add up and make a negative number. Well, positive 9. We know that we could have a 9 times a 1, right? Well, if they're going to add up and make a negative, they're both going to need to be negative. 3 and a 3, in order to multiply to make positive, are going to have to both be negative. Well, when you multiply those two, only one of them is going to multiply, or both of them multiply to make the 9, but only one of them is going to add up to make the negative 10. So, with my positive 9 here, crap, you're right. Got my 6 over there. With my positive 9 down here in the box, looking at what multiplies to make my 9 adds up to make our negative 10. We're going with our winner here of the negative 9 and negative 1. So then our combined like terms across our middle are still going to add up and make what we want here in our middle term, but multiply to our back.